Hello and welcome back to the show. My name's Relevant. This is Do All the Things. And on today's episode, Project Overdrive makes a return where I built a tube-based overdrive for my Marshall JCM 800 in this old RCE phono amp. So where we last left off, I don't know. It was over a month ago since I last filmed this, and I've kind of been tinkering around this. This isn't a project I've been doing on camera. It's a project I've been doing off camera. Not exactly sure what directions I should take, and eventually finding my way to where I am now. So when we last left off, I don't think I had made the base for it. I made a nice base for it. Basically a scrap piece of trim wood, some feet I found in scrap parts, and those bitey nuts whose name I forget right now. Put some foil on it, boom, we bolt it down to there, and it's more of a complete unit now instead of just kind of a chassis floating around. It's nice because it actually clears the handle of the amp, so it sits nice on the amp now. I've done some improvements. I added a fuse. This thing had no fuse. I've replaced the jacks with isolated jacks, and I've completely re-spec'd out the grounding. You see those diodes that aren't zapping me? That's part of a ground lift network. You know, you have a combination of diodes, a 10 ohm resistor, and a capacitor. They separate chassis ground from circuit ground to avoid ground loops, which is important because you're plugging this into an amplifier that's also tied to ground. You end up with a ground loop. Made it a little bit quieter. I've also done some redesigning on the circuit itself. You know, first off, I did some work on the power supply. I've seen designs where the rectifier directly feeds the choke before the filter cap, but I decided to take that approach here to give it a try with the random 20H 50 milliamp choke that I had. Then we got half a 32, 10K, another half a 32, and then 10K going out to the tube itself with a 10U450 filtering it. Yes, this had a 50-50 capacitor in it before. I also one scrapped out of the Marshall. I bought it its own dual 32 capacitor now, just to freshen it up, thinking that I wouldn't need that much filtration. But this thing still has noise. Even muted. Listen to that. Should we expect anything less? This thing was not designed for a high gain circuit. It's possible that there's no way to make this quiet because, well, this old transformer's just throwing off too much RF, screwing with stuff. And because it's just a single-ended preamp, it doesn't have that push-pull phase cancellation trickery that a full amplifier would have. There might be some secrets I don't know. Maybe I figure it out. That said, it is quieter on the other side where I actually use it. This room tends to be a bit noisy for whatever reason. Maybe it's all this gear that's running around me right now. I have heard that, you know, sometimes you need a lot of filtration in a single-ended amp. That's the reason why some single-ended amps might have like up to 200 UF of filtration on their B+, even though you technically don't need anywhere near that much. I have an experiment I want to do with this thing. Now, I do believe when we last left off, I had built the DC filament regulator module, and it works well, kind of. Actually, if I pull it out, it gets noisier. But that's because the center tap resistors are on the module itself. I believe we built the relay module in the last thing, and I don't really believe this is causing any of the interference, even though it's taking some of the signal and exposing it externally. That switch seems to be a little bit more worn out than I expected. But it works on foot switching, and the foot switching works well. I changed the tube socket with the ceramic one because the old one wasn't compatible with this nice red tube shield. I don't know how well this red goes, but it's just a little splash of color just to make it look more interesting. That was part of this project's prerequisites, to make it look interesting. I acquired a shipment of Russian tubes, so we have this really nice looking Russian 5U4C. It's kind of like a 5Y3. It's a cross between a 5Y3 and a 5AR4, and it really improves the aesthetic over the one that was in there before. Now, some of the important gains that were made were in the preamp circuit itself. I have been studying the Diode 250 because I have a Diode Malmsteen pedal, which is the same thing as the 250. Try to figure out what makes it click. I'm starting to experiment with op amps and whatnot, and I'm going to be building a clone of that. Stay tuned. But I decided, well, an op amp overdrive, its secret sauce is those clipping diodes. So let's throw some clipping diodes in this and see what happens. So we have our input going to a 22K grid stopper, 1 meg after that for the sake of convenience, goes to the 12AX7. And what I've settled on is I got a 120 on the top, a 1.8 at the bottom with a 22 cathode bypass. We move on to an 0047. I needed an 001 before or else this thing sounded farty, but I was able to up it to an 0047 with the clipping diodes. This TED-K kind of smooths things out, and it did fatten up the tone a bit, and then boom, a pair of 4007s. Then I added a volume pot, 250K linear to the output. Did I mention I spec'd out the ground in this? There's no more ground loops, isolated jacks. And then the tone pot is basically when you have the clipping diodes. You know, to look at the Jubilee real quick, we have the clipping diodes and a capacitor. Even up here, we have the clipping diodes and a capacitor. There's always a capacitor that goes along with the clipping diodes because the clipping diodes themselves will clip a bit too hard. The capacitor adds a little bit of recovery time to the end of that slope. I'm not sure how to describe it better than that, and I don't feel like drawing a picture at the moment, but you need a capacitor. And I noticed the texture I got off the clipping diodes changed with the capacitor value, and I couldn't make up my mind what capacitor value I wanted to use, so I decided to use all of them by basically hooking an 0047, which would have been the max value I'd want to use on its own. It just sounded a bit too fuzzy, up to a potentiometer so I could dial in the amount of capacitance. It half works. It doesn't work as well as straight up changing the value. I kind of want to put a rotary switch on there to just directly select between different capacitors, but it does give some effect. And oh boy, this really made it. It was one thing to just have a clean boost and force feed the front end. The 800 didn't mind that. It could work with that and got a pretty decent tone, but it wasn't perfect. Especially, it was missing certain harmonic content. And then you look at the overdrive pedals, they have some form of clipping. That's just some of the secret sauce that makes the metal distortion I'm going after in an amp like this work. To top it all off, this overdrive unit did not work well with the Jubilee at all. It overvolted it. It didn't work very well with the 900 project, overvolted it. The 800 is the only one that could really handle it, but now with the clipping diodes, it clamps down that output voltage. A guitar is gonna put in maybe 100, 150 millivolts at the most. Those clipping diodes, they kick in at 0.6 volts, which means no more than 0.6 volts can friggin' pass through this. And that seems to make all the difference in the world. So let us, you're probably thinking, we're gonna get to hear it. Oh, right now. Let us give it a quick play. Because one thing I'm loving about this guy is she brings it to Crunch Town, bud. Bear in mind, my skill is not in cab miking. It sounds better in person. Now, just for the sake of argument, I'm gonna roll through some of these settings here. I can crank that volume now and like not overvolt the amp too much. Works like a proper overdrive now. So how about that tone knob? You're gonna notice it's very, very, very subtle. It's gonna get a little bit sharper when I set it low, and it's gonna get muffier when I crank it up. Either way, I am very happy with the way this has turned out so far, and I've been enjoying playing it, especially through the 800, especially driving the 6N2P tubes that I have in here right now. Not the EVs, old school. This amp loves those 6N2Ps in V1 and V2. Really gives me the mid grind I was after. So what I want to do today, other than update you on what I did with this thing, is I want to do a little bit of experiment there to see if I could do something about that hum. The theory being that if I could filter all the ripple out of the power supply, maybe I can sort that out. Do I feel like setting up the oscilloscope? Ugh. Because, you know, if I flick this switch off real quick, turning off the power supply, there's still plenty of voltage left in the reserve capacitor to keep the circuit working. See? Now you might not tell, but it's still working when I switch it off. Now, if you've been following the comedy, you know that I've been starting to experiment with Mosfet voltage regulation in these tube amplifiers, and I have been having great results. With the exception of I blew one in 900 project, but then I fixed it and it hasn't blown since. I think it was a fluke. I want to see if I integrate that kind of voltage regulation into here, if that's gonna solve my problem. Silicon voltage regulation is a dirty trick that's been used since the beginning of time by electronics developers to purify sound. The concept is, okay, so this square is your voltage regulation, right? And then you have maybe, let's say we have 400 volts. That's the idea. Going into the voltage regulator, and it has some ripple sitting on top of it. Those ripples is the form of voltage spikes, right? So say that's 400, maybe that's like 400.1 volts. It's not actually going to look like this, but this is just for the product of illustration. Now, say the VRM, we bring things down to 300. Let's look at the schematic. Our target supply for the tube, 372. So the VRM is going to bring 400 down to 372. And the VRM doesn't care that it's rippling. It's going to clamp that down. So what we end up is, you know, DC that's relatively flat, because as long as this voltage is lower than this voltage by a margin wider than the ripple itself, it's going to come out smooth. So the question is, if I go and remove as much of that ripple as possible, is it going to work? So the concept is simple again. Gate, drain, source on a high voltage MOSFET, drain being the V in, source being the V out, and then gate being you set your voltage reference. We're gonna have a 1K buffer, and then that is going to get reservoired by a capacitor, probably a 10U. And see, part of how this is gonna work is that 10U is going to hold the voltage at a constant. So even though this guy changes a little bit, well, past the voltage divider, this capacitor is not gonna be able to respond fast enough. So we need a voltage divider to set our voltage. That's going to be a combination of two resistors connected between V in and ground, referencing into the gate. So we have to do our math now. Hey, it's not healthy for the pencil, don't do that. I want minimum 1K per volt. So 400K, 470. Oh, let's face it, I already did some of the math. If I take a 22K resistor and a 470K, that's gonna give me a total of 492K, which will get me a dissipation of 0.8 milliamps. Well, I was out of frame there. And then we do our percentage math. 470 divided by 492, that's going to be 95% right there. So of course, 400 times 0.95, we're gonna get a target output of 380 volts. Now, is that gonna be enough to filter the ripple? Coming down 20 volts. If I had a better oscilloscope, I could probably measure the amount of ripple, but I don't have a proper oscilloscope, so... However, that is a good target for this first drop. So coming off the choke, going between these two sections here. Now let's see if we can prototype this. Oh, bunch of breadboard. Oh, I don't have a MOSFET on it. All right, random 500 volt MOSFET that I know will work. Go ahead, get your cans covered in white schmoo because the MOSFET's a bit dirty. I had a spot on here to set up MOSFETs. I'm gonna get all this other crap off of here. Okay, I need a 470K and a 22K. All right, so this here should be a reasonably drawn there's extra crap going on here. Ignore it. This should be a reasonably drawn facsimile of the circuit we need. I just have to hook it up. which is always a daunting process because working on this thing with so much wart sticking out of it is, you know, not quite ergonomic. Okay, it's use of the tube. We need to go in here and lift one of these situations out of the way. So let us remove this 10K resistor here, and that is where we'll, come on. That is where we will intercept our voltage. I gotta get some linky looks in there. Careful, they might be a little bit energized. Black will be out, red will be in. I gotta clip that all the way down there on the capacitor. And then we need a ground. Whatever, that'll do. So we'll kind of set that aside. Ground will clip here. Input clips air. Output clips air. That should work now. No smoke. Okay, what do we have in camp voltage? Just grab a ground here somewhere. So our input should be like 400, 377. Something's pulling it down. Oh, what's our output? 356. Okay, we're gonna have to do some more fine tuning on this before it's probably gonna do what we need it to do. But how does it sound? The same. You do nothing. You do nothing to help the situation. Wonder if it's an impedance issue. Oh, it still sounds good, but why you no quiet? Oh, I've seen other designs maybe pull it down more. Maybe we could try, well, let's see what happens if we reduce the voltage more. We'll change out the 22K for something more, you know, just more. We'll put a 47K in there. That should bring the voltage down to 90%. Hey, let me guess, that fried the Mosfet now, didn't it? 331, 374 to 331. That's 88%. Still humming the same though. So perhaps it's not a voltage ripple. So perhaps it's not a voltage ripple issue. Well, honestly, part of me thinks that this is just, you know, this is as good as this design's gonna get. Fortunately, for my purposes, that hum's not too distracting, not while I'm playing. But you know, we have a high sensitivity input stage. That's a V1 on a 4+0 circuit effectively at this point. And it's on this old chassis with, you know, I'm not gonna call the layout sloppy underneath because it's the best you're gonna get using point-to-point wiring in a repurposed old chassis like this. But maybe with a better layout, maybe this transformer's throwing off too much RF. Maybe this is as good as this is gonna get. Either way, it might be a little bit more to the drawing board, or maybe I just use it as is for now and enjoy it for the weird thing that it is, and then call it good. So I don't know. All right, after engaging in some experimentation, I determined that the whole idea of running the choke directly off the rectifier with no filtration is not a good idea. I've gone ahead and put it back to the configuration where the rectifier feeds a filter, then chokes, then filters, and that works way better. If you can hear, the noise floor has definitely decreased. Now I've done some experimentations with various filtrations to see if adding more UFs in there is actually gonna make a difference. It does not. Now doing this way kind of takes away certain opportunities for RC if I wanna hit my voltage targets. So I do believe I'm gonna go ahead and stick with adding a voltage regulator into here. Combination of a 56K with a 1 meg gets it down to the percentage that I want to hit my voltage targets, because I like the sound of it before. 372 volts on the output for about 240 on the anode of the tube itself. So yeah, 371. And on the tube, yeah, 241. Bam, target. Voltage regulator circuits are really coming in handy for troubleshooting this. So based on my experimentations, I've determined that this power supply circuit's running clean AF right now. This noise is not coming from my power supply. Not anymore, it was. But now, not a problem. I believe the last amount of this hum is just coming from the layout of the machine itself. Like if you're playing a guitar with a high gain amp like this pupper right here, and you start standing closer to the transformers, observe. guitar starts picking up RF induction coming off the power transformer. And I'm thinking that's simply what's going on here. And this particular design, it's just too small. It's just too small. Audio bearing circuits are just entirely too close to this pupper right here. It can't help us. It cannot, you know, maybe there's some trickery that I can use to like sample hum and phase it out, but I would have to get a sample of that exact hum. And I've been playing around and I can't quite, you know, just can't quite. And it's not in the input because this resistor here is pretty much filtering that all out. If I touch this to the input, nothing. Kind of wish you could just attach it to part of the circuits and get results that way. Nope. Heater. Nope. 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 So yeah, I don't know. I think we're overall just, oh, did my lamp burn out? WTF. I thought that lamp was a good one. Oh, that's disappointing. Good thing I got spares. I've been staring at this thing for an hour now. I didn't even notice the lamp go dark. This is a DigiKey CM755. It's a 20,000 hour rated lamp, so it should last. So yeah, I don't know. I think we're good here. I'm gonna go ahead and install this voltage regulator circuit into there, call it a day. And again, this is a noisier room. It might be different in the other room. Yeah, okay. So, Project Overdrive, mostly a success with just a little bit of failure. But what it does well. I'm enjoying playing it, and I'm gonna keep playing it. And maybe I'll tinker on it more, and maybe there will be a follow-up in the future as to what I have since accomplished on it. See if I've solved any problems. See if I've made it sound better, etc, etc, etc. Stay tuned. Oh, bud. So dramatic. Stay tuned. All right.